Automation helps people minimize tedious, repetitive tasks on the job and in their daily lives. Automation utilizes technology and robotics to assume tasks like cleaning, operating devices, or accessing information. How can Toyota, a leading vehicle manufacturer, integrate automation onto their production lines to improve safety, reliability, and affordability of their vehicles? TMMWV, or Toyota Motor Manufacturing West Virginia, is the only combined engine and transmission plant in North America. The 1.9 million square foot plant produces 650,000 engines and 740,000 transmissions a year. These essential parts then become the foundation for Toyota vehicles manufactured all over the country.
Hi, I'm Jacob Plasters, Engineering Manager at Toyota West Virginia, and here I'm responsible for the Production Engineering Group. During routine maintenance, a Toyota service technician identified an issue with an oil leak.
Automotive oil leaks can cause severe damage to an engine and also to a car's overall performance. Additionally, there can be environmental consequences. Leaking oil can become a pollutant, contaminating the ground, air, and waterways.
We approach each customer concern with the same mindset, that one oil leak is one too many. So we assigned a group of engineers to find the root cause of the problem.
Hi, I'm Penny Pataki. I'm a production engineering specialist here at Toyota West Virginia, and my responsibilities are dealing with problems that are on our production lines. We identified the root cause of our oil leaks as the three-point area surface on the engine. The cylinder head and block are the main components of the engine and allow oil to continuously flow to lubricate the parts. We determined that by buffing the cylinder heads and blocks, we could eliminate the oil from leaking. However, this step of buffing the cylinder head and block did not currently exist on our production assembly lines. So Toyota remedied this by adding a team member to manually buff the head and block. So this impacted our manufacturing process by adding 2 team members on each shift to buff the cylinder heads and blocks. This approach did not allow Toyota to have the best use of its highly skilled team members. After brainstorming, we knew automation could solve our issue. We knew automation must include a collaborative robot.
Collaborative robots are great for small spaces and safe for working around humans. If a human enters a restricted safety area around the robot, it will stop all movements.
It allowed team members to do more value-added work and relieve them from a monotonous, repetitive manual buffing. To begin the process of automation, we must identify all the human variations of our team members. They must be replicated in order for the robot to complete the task. By identifying the human variations, we can standardize the process and successfully program the robot.
Here's your challenge. Help Toyota engineers automate repetitive tasks on the production line to best utilize employee skills.
To standardize our process, I monitored our team members over different shifts to identify their processes. I observed their motions and the areas they were buffing on the heads and blocks. While monitoring our team members, we identified the force and pressure as 2 of the main variables that needed to be programmed into the robot.
In order to properly program the new robot, Toyota engineers must take into account human variation. Each team member applied a different level of force and pressure while buffing the engine, so engineers must determine the average deviation to properly program the robot. This data table shows the measurements collected from 6 different team members, or TMs.
So I collected measurements for roughness so I could develop and calculate a range that created the spec for the robot. The tooling on the end is what the team members were actually using to manually buff. So we took the exact same tool and grinding wheel that they were using, developed through the 3D printer, and added a tool holder so that we could have it in the same stance that the team members were using. So now that the collaborative robot is on the assembly line, we're continuing to monitor the variables that we noticed when the team members were doing it manually, which is force of being used, the speed of the grinder, as well as the tool count, which were all variables that we're not able to control with our manual buffing. For us, being able to bring new technologies in will not only expand the processes we have here, as well as help our team members to not have such a burdensome job.
How does your solution compare to Toyota's solution? If you like solving this challenge, consider careers like the ones profiled in this video: engineering manager, engineering specialist, production engineer, production control specialists. Automotive production engineers like Penny utilize academic and professional skills to solve challenges like the one featured by Toyota. How did she and her colleagues identify their personal interests and develop the required skills to pursue a rewarding career?
My name is Rahul Sharma, and I'm a ZR engineering specialist. What I really was good at was, making small, cool, gadgets that, would help my parents around the house. And that's when I tried out manufacturing, and I realized that that was something I was going to fall in love with.
While in school, even when I was younger, I always was into math and science. I was always trying to take things apart and understand how they work. I was typically the only girl, and even into college, I was one of very few in my classes. So it was a hurdle, but at the same time, understanding that we're all the same. It doesn't really matter whether male or female, we're still learning the same information. And it gave them a different perspective. Sometimes my insight into things was a perspective that the guys didn't necessarily understand or even take into consideration. So even still now, my perspective, I think, is still very valuable.
Engineering professionals often hone an early interest in math or science, beginning with high school level courses.
My school did have some very small starter engineering classes. I learned how to do some very basic CNC programming and even learned how to program some remote control cars, things like that. So I was in those classes with the boys. I was there with my brother most of the time, where it really got me excited about doing things with my hands and gave me a little understanding of the stuff that I was learning in math in my science class.
Now, I went to a specialty program in high school that specialized for engineering classes, and from there I was able to build a stronger foundation in terms of the basic engineering skills that are required out in the industry, and then later carry those into college and further my career. Science classes, chemistry, biology, most importantly physics, I believe. Math classes are also very important in terms of trigonometry and algebra and calculus. And all these courses will really help you in your engineering career. But I think math courses and science courses not only apply to engineering itself, but they're great courses in terms of, figuring out where you want to go in life and what you want to do with yourself.
A career as a production engineer generally requires a BS in manufacturing or engineering, industrial, electrical, or mechanical. Within those disciplines, consider advanced coursework in specialized areas such as logistics and supply chain management, quality control, materials, and operations management.
Diversity is a big part of Toyota in the sense that we understand the importance of bringing in different ideas, different values, different experiences to the workforce.
Toyota's big on problem solving, right? So when they're interviewing people, they're looking for folks that are problem solving and have some engineering background, but can also go on the floor and find problems and solve problems. To be a good engineer at Toyota, you need to have good engineering skills, but you also have to have very good interpersonal skills. So in manufacturing, there's a lot of different avenues you can go, but even at Toyota West Virginia, all the way up to our president level, most of our management have some kind of engineering background, whether you're a production group leader, a production assistant manager, or even engineering. Right? There's a lot of different avenues you can go with an engineering background.
The engineering field is just so vast that, I'm pretty sure that if there's anything out there that you're excited about, there will be some application towards engineering.
You have to own your passion and just be committed to what you want to do.
My name is Leah Curry. I'm the president of Toyota West Virginia, and I've been working for Toyota for over 20 years. STEM, science, technology, and engineering math enter into what we do every day. But even more important, critical thinking, problem solving, teamwork, the ability to present and work with others as a team and solve those problems is even more important for us every day. What excites me about the future of manufacturing is the fast-paced environment. Today is different than yesterday. Tomorrow will be different than today.
The automotive industry accounts for 8 million jobs within the United States alone. By 2026, more than 25,000 production engineer positions will become available in communities across the nation.